Hello everyone, today I am going to deliver another lecture on reaction shear force bending moment calculation by moment distribution method for frame. Okay, so first of all I will show that some theory of moment distribution method and then give some examples of moment distribution method for frame non-SOE and SOE member. Okay. So it's been seen when the structure is indeterminate, then we can use moment distribution method, force method and stiffness matrix method. So okay, in this case we have been use moment distribution method to finding the force and shear force bending moment diagram. Okay, so let's see some theory. Here is the distribution. What is the distribution factor? This is the distribution factor, which is moment is a junction is beam and distributed to the beam, and it is calculated by dividing the stiffness of connected beam by the sum of the stiffness all over the beam at the junction. We have been seeing here the stiffness of member and total stiffness of joint. So you can see distribution factor KAB BA equal to KAB divided by KBC into KCA into CA, which is called KBA in summation of K. What is the carryover factor? It is the ratio of the moment transferred to the far end, and the moment is applied to the end of the beam, which is M prime. This is the M prime is the fixed support equal to half of M. So this M, the pin support will be carried to the fixed support only half. Stiffness factor. The stiffness factor is the ratio of the moment is inertia cross sectional beam is length. The stiffness factor is measure the resistance of the bending. So we don't need it. So if we go to the here the fixed in moment. So here is the fixed in moment as the some formula you must be memorized when the fixed in and the UDL then W by 12 and the fixed in and load is P and PL by A, and others are given here. You should memorize. Okay, so we can see here the some stiffness factor modification factor K 4A by L. This is the 4A by L when the far end is fixed. This is the far end fixed. When the far end ruler, then we can use 3A by L, but we should not use. We can always use 4A by L. And we can also use 3A by L when the pin symmetric and loading, but we will not use this, and the symmetric beam with asymmetric load, but we will not use this. We just keep in memorize 4A by L and far end is fixed, and we can keep the fixed in moment WL square by 12 and PL by 8. And we can use the distribution factor, which is DF KAB equal to summation of K. At first I have been shown here. Keep in mind the fixed support distribution factor is always 0, and the free support is always also 0. The hinge support is always 1. The distribution factor is 1. What is the carryover? Carryover we have been shown here. The carryover is always half. Okay. So we've been seeing the same formula. We can just use this stiffness. What is the stiffness? Stiffness cascade is the simply as the resistance of the object to change the length. For example, rubber band. Sign convention. What will be sign convention? The we will establish the same sign convention as that is established for slope deflection equation. We can say the clockwise is positive, anti-clockwise is negative. What is the fixed in moment? Fixed in moment at the wall, at the fixed and joint is loaded member are the called the fixed moment. What is the distribution factor? The distribution factor moment M is applied to the fixed end and joint at the connecting member will each other supply the point, and resisting moment is necessary to satisfy moment equilibrium at the joint, and then fracture on total resisting moment supply in the member is called distribution factor. Okay, we can see here the stiffness factor M equal to K theta equal to A. So if we multiply M by divided by K, then we can found this. Okay, so distribution factor we have been seen K into sum of K. now we are going to the a math example, because this is the 3D part is completed. Now you can see the math example of non-sway. At first we have been shown the non-sway. Okay, so let's see. This is the non-sway. Use the moment distribution method to draw the bending moment diagram for the frame shown given. EI is constant, we have been seen here. So distribution factor DAC, this is the AC, is 1, and DEF, where the EF is 1, and FD is 0 because the fixed support. So distribution CA. So what is the CA? This is the C, and this is the A. This is the pin support, and this is the pin support. That's why we are saying this is the 1 and 1. And CA is a joint. What will be the joint distribution factor? CA divided by C into CT. C into CT will be used for E by L, all the whole for E by N, and CD we can use. This is the CD joint, and 4EI by LCD divided by 4EI by LCD divided by CA, and found 40, and the upper is 0.60. If we multiply this will be 1, because this joint is always 1. The CA we have been found 60, and CD we have been found 0.40. Okay. Now you can see in the same way DE multiplying, this is the DE, this is the 3 joint. You can see DE divided by DE DC DA. This is the DE DC DA DF, and found 0.43. In the same way we can use DC and found 0.28, and found DF which is 0.28 also. If we sum all this, then it will be 1. Okay. Now go to the fixed moment, WL square by 8, as the point load is given, as we've been shown with the 75 PL. Okay. Now we can go to the there is some wrong, I think. CA and SE will be WL square by 12. CA SE, no, it will be 8, because these are the not fixed, because this is the pin and this is the pin. It will be CA SE WL square by 8. Okay. If we go to the here, there is a fixed support, there is no pin support also. Okay. So if the fixed support, then WL square by 12, we can use this. Okay. So this is our diagram we have been seeing: joint A, B, C, D, E, F, and member A, C, CA, CD, and DC, DA, DF, and FDs. All this member and distribution factor have been found here. All these distribution factor, and taking all the distribution factor here. And fixed in moment. This is the fixed in moment. All the fixed in moment. I've been taking all the fixed in moment. So unbalanced moment we have been found in here. We have been shown 3.5 minus 2.61. So it will be 0.687. If we multiply with 0.40, it will be 0.35. 0.675 into 0.60, it will be 0.25. As the moment distributed balance distribution, that's why it will be negative. If this is positive, that will be negative. If this positive, that will be negative. If the negative, then it will be positive. It will be 100%, because the distribution factor is 1. 3.5 into 1 into 1. Okay, so we've been we've been found here joint C. It will be divided DC DA DF 6.5. It will be multiplied with 0.28, then found 0.75, 735, 2.625 into 0.43, and found 1.128. 2.625 into 0.28, and found minus 7.35, and so many things. Now we can see here D2F, the carryover is always half. which is 0.725 divided by 2, which is 0.375. Then C2D and D2C, it will be carry over. This is the C2 and D2T. 0.735 will divided by 2 is 0.375, and 0.5 and divided by 2.75, and add to C2A also. This is the as this is the there will be no chances C2A. Okay, so we can see here in this case we can calculate here this 0.37 multiplied with 0.40 and 1.05, 0.37 into multiply with 0.60 and found 0.22, and this case found 0.17 into multiply 0.28 in 0.50, 0.17 into multiplied with 0.43 found 0.070. It will be as this balance moment distribution. That's why if this value is positive, then it will be negative. If this value is negative, then it will be positive. We have been found this is the negative. For balance purposes, we have been used positive value. In this case, we have been taking all these below. It is close to 0. Now we can stop our trial and finding the moment. We have been found the moment is here. After getting the moment, then we can draw the shear force and bending moment diagram also. So let's see. Okay, so I've been finding all these below. We just the same math we have been I just calculating here. KAB 4A by L, KBC 4, KCD, KCA, ET, all the calculation I have been shown here. The distribution factor also I have been shown here in depthly, and then joint member I have been also here. Now we can draw the moment diagram is here. So after getting this summation of all moment, this is the summation of all moment, so we can draw the moment diagram easily like this way. Okay, so the SOA is completed. Now we can see the non-SOA, the non-SOA member is completed. Now we can see the another example which is non-SOA. Okay, who is the SOA? Sorry, I'm just saying wrong again. So moment distribution from SOA member. What is the SOA? SOA, that means it is the deflected. So member will be deflected like this. It will be deflected. So artificial joint applied, no SOA. What is the SOA? We can use the one load. An artificial joint removed after SOA. So we can use the remove the load R. Okay. We can see determine the moment of each joint section frame is shown here. A is constant, so all this given is here. So RA is we can see one is fixed, one is a pinch support is here, and RA is applied, but another is RA is removed, as we have been seen here. Artificial joint removed, so there is no joint. So here is another artificial joint is applied. This is the applied. Okay. So in this case we've been shown here this diagram equal to this two diagram, as EA is constant, KAB equal to 4EA by L. So EA is constant and L is 5, just 4 by 5, 4 by 5, 4 by 5. And distribution factor AB and DC, and this is the AB and DC. The fixed support is 0, and BC is CD is 5 as given here. The fixed moment PL by L square divided by AB square, because this is not equally distance, it is the unequal distance. That's why PAB square divided by A plus B square, which is 10 minus 10.28. The same way for CD, PA square B divided by A plus B, which is 2.5. Now we can calculate this is the joint here. we can see member A, B, BA, CD, CD, CB, CD, DC, and distribution factor we have been already calculating here. Just taking all the distribution values here, and fixing moment we just finding the fixing moment is here. So B point, so this is the B point fixing moment. If we multiply 8.5, then it will be 5.12. If we multiply this, it will be 5.12. And there is a 2.56 for joint C. If we multiply 2.56 into 0.5, it will be 1.25, and 2.56 into 0.5 equal to 1.25. It is the positive, and it will be negative for balance purpose of moment distribution. And then carry over C to D. This is the C to D, and C to B, and B to C. So C to D is 1.25 divided by 2 is 0.68, and C to B, this is the C to B 1.25, 1.28 into divided by 0.68, and B to C 5.12 divided by 2 is 2.5, and B to A, this is the B to A 5.12 divided by 2 is which is 2.56. And in this case we can calculate all things, and when we'll stop when the result is close to 0, then we stop. We don't need to trial. After finding this value, what we will do, this is the moment we have been found moment. So all moment 2.88 positive, clockwise positive. This is the 5.75 and minus 5.75, 2.75, 2.75, 1.75, and RA is applied. So how will get the value of RA? Then taking the moment of MB, this is the B point, and finding AX equal to 1.7. This is the AX we have been found. And in the same way we can take in the moment at C, this is the point of C, and found dx equal to 0.81. And if we take the summation of f of x and f of y, then all the summation we can find R value 0.90. So this R value is 0.90. Now we can calculate soy member. The same joint A, B, C, D, the member is given and distribution factor is given, but the change will be moment distribution here. As we have been shown, the AB we have been seen here. AB is 100. We just take in left. You can assume 50. You can assume 20. You can assume so many things. But we have been assume 100. And BA is assume is also 100. So which is BA. At first we have been taking AB. What is the AB? This member AB. And BA also 100 for balance process, and CD and DC, this is the CD and DC is the 100 we have been taking. So now we can see here, if we change the color, the point B here, point B 100 into 0.5 equal to 50, 100 into 0.5 equal to 50, and 100 is 0, so it will be no 0, it will be 0. So another point joint C, so we can see joint C here, 100 into 0.5 equal to 50, 100 into 0.5 equal to 50, and 100 is letting here. Now we can see that B to A, this is the B to A. 50 divided by 2 is 25, and B to C and C to D. Okay, so B to C 50 divided by 25, 50 divided by 25, and C to D. This is the C to D, 50 divided by 20, 25. And in this case, second one we can see here 25 into 5, which is 12.5, 25 into 5, which is 12.5. And the same way 25 into 5, this is the distribution factor, multiply, and 12.5 and carry over also. The same things we can use 6.25 into 5 into 1.35, 6.25 into 5 into 1.25. The same way 6.25 into 5 equal to 3.15 and carry over. And then we can also another distribution factor, and trial and trial, and after we can see here it will close to 0. That's why you don't need more trial. We can stop here. After getting, we've been seen here 80 minus 80 is anti-clockwise, and minus 60 it is also anti-clockwise. CD we can see here, this is the CD, the 6 we've been seen minus 80, this is the minus 80 anti-clockwise, and anti-clockwise also 60. So after dating, we are taking the moment of B, this is the point of B, and found AX equal to 28, AX equal to 28, and taking the moment of C, this is the moment of C, found dx into 28, dx into 28. Now we can take the summation of f of x and found 28 into 20 into 56. So these are our value. This is our answer. And here these are the 0.56, 56, and m prime is x found all the number of the b. In the same way, we can use this moment, then we can draw the moment diagram also. You can see another example. Determine the moment of each moment frame is given shown in below. The moment joint is indicating is here. We have been shown all the member equal to these are the we can use pin support NR, and the pin support is removed, but the length is imbalanced. So you can if you design the bridge, then it can help you, because the bridge, most of the bridges are like this. This is the water, this is the bridge. Okay, the bridge is like this. So you can calculate distribution factor is like this way, and fixed in moment we can use this way. Carryover is carryover is always 1 or half. We can finding on the joint member distribution factor, and carryover, and finding R value. Finding on this moment we've been taking the moment 0.5 is positive clockwise, minus 0 minus 14 anti-clockwise. After getting summation of f of x found ax dx found. After ax dx, then found RA 1.89. Now we can use for soy calculation, we can use this formula, and found FAD this value. And after getting this value, so what can we do? So we can same way we can use the SWOY diagram. So you can assume this 100 into 100 by B, and this is also calculated 27.85 we've been founding here. How will get 16 moment BA and founding the delta, and the 15 moment CD and founding the delta. Delta means the lateral displacement. So BA, that means this BA 6EI by L square divided by BA, and if we reverse here, then we can found the BA, and 15 moment 3EI by L square CD into L square and forming CD. So where is ABCD? This is ABCD. Okay. So BA, that means this is A, this is the B. So BA means this value, and C, this is the D. This is the D. So CD value has been found in same way, and since MB is 100, we can assume. So we can compare B and CD. After the compare, then we can find in the CD value, which is 27.28 keep fit. Then we can assume CD below 27.87, which is calculated, we will not assume. And in the same way we can calculating all these value. After getting the summation of I will calculate 10. It is found in here. So if we calculate here join B, this is the join B, 100 into 0.65, 0.615 in 60.1, 100 into 0.351 and 38, and carry over is 61.5 divided by 2 is 30.75, and this carry over 38 divided by 2 is 19.25, and this is the half percent here. And point C, we have been seen point C, 27 into 0.5, which is 30, 0.89, 27.7 into 5, 13.89, and carry over is 5. So now we can here the same as it is, 6.59 into 3.85, which is 28, 2.65, 6.895 into 6.658, 2.75, and thus in this same way this, and same way this, and same way this, and same way this. And after calculating here the founding moment, minus 69 is anti-clockwise, and minus 40 anti-clockwise also. This is the 0 and 0, and it will be 20 minus 28, so anti-clockwise. After finding this, taking the moment at B, this is the point B, and found AX equal to 11, and taking the moment C, this point, and found DX equal to 1.55, and after calculating R, all these below, summation of f of x, and R below, R prime is 12.55, and finding this below, we can use R minus R prime, use the previous equation as been shown. This is our equation. This is the 0.288, the 288 R minus R prime 0.57. I will get 0.57. This is the 0.57, and R minus R prime into R prime is 80, and this is the 60, minus 80 and 60. This is the minus 80 and this is the 60 from 7 outside. We can calculating here. After calculating, we can use this all this value has been found here, and drawing the moment diagram also. Now we can see determine the moment each joint frame is shown here. The constant we have been seen here. So distribution factor we have been putting here, moment distribution. 16 moment is frame. After getting join member, distribution factor 15 moment, and balance distribution balance. You can see after getting on this moment, this is our moment, the 0, 5.97, this is the 5.97, and after this value we can analyze all this here. I'm just skipping here, as you know. And we've been forming this diagram, and vertical distance also we've been forming this below, and 100 we've been taking length, taking assume 15 moment. So this is the taking assume, and this is the calculated, and finding finally moment we've been found as summation of this summation of m, all this, and finding this moment diagram, and calculating all these things, and we can form finally R prime. And if we go to the R prime, then we can use here R minus R prime into moment, and putting all this data and finding moment is here. Okay, so I think you can understand. If you have any problem, then let me know. I hope that it will help you. Thank you everyone.